Javier Militino works in Comansa, one of the lead companies in tower crane manufacturing, and is based out at Comansa head office in Spain. He takes care of the coordination of the marketing of the group across the different locations and also all latest technological advancements. He closely follows up the market development and technical challenges, evaluation in the construction technologies, is putting on tower cranes technical requirements. We also have with us Elizar Raya, Group Sales Director, and Mr. Sheetal Malik, Country Manager India from Comansa. Over to you, Xavier. You can start with your presentation.
Okay, thank you very much. It's a real pleasure to be today with you. Greetings from Spain. This hybrid mode is good for avoiding COVID pandemic restrictions, and I'm really happy to share with you some insights in fast and efficient erection methods using tower cranes. Modular and precast construction offers many advantages, such as a lower cost, increased sustainability and safety in quicker build times. While challenges remain, transport and crane hire are extra costs associated with modular construction. The increasing adoption of precast is changing the tower crane market around the world. It's something that we see not only in India, but in the rest of the world. This presentation looks into the characteristics of a tower crane should have to be suitable for this application and the insights found for a more efficient erection methods. Today, I will present a brief introduction and context of the tower cranes in this industry. Later, I will discuss about the tower crane requirements on this kind of projects. Briefly, a solution definition with just a case study in India. The fourth chapter will be talking about the efficient tower crane use references. Okay, I will go ahead with some examples in India and in other trending setting countries. And last but not least, the question and answer time. Okay, let's start. More than 70% of people will be living in cities by 2030. Okay, you can see on the right table that Delhi is the second most populated city in the world behind Tokyo in Japan, with more than 31 million of people and growing almost 3 points comparing to last year figures. Kolkata is also another Indian city in the top 20. Okay, this leverage very many urban development challenges. The first of these challenges is the shortage of skilled workers. This issue that has dogged construction for years and the use of new technology and methods, such as automated equipment and precast construction, is viewed as one way of getting around the problem. The shortage is now even more severe following Brexit in UK and the COVID-19 pandemic, which means more clients and constructors need to turn to off-site solutions to achieve greater certainty of delivery on time and on budget. I have just read that according to the Royal Institute of British Architects, modular construction or panelist solutions can reduce the number of employees required on a construction site by up to 70% and cut overall building cost by between 20 and 40%. Second, cities are growing fast. They need housing and health facilities. Furthermore, cities are becoming eco-friendly and more sustainable. Governments around the world put increasing pressure on the construction industry to reduce emissions. The usage of modular construction is surely only going to increase. And the fourth bullet point, there is an existing pressure to adhere the manufacturing standards, component traceability, and cost savings. Okay, next slide, talk about prefabrication and modularized construction. Okay, we have an improved productivity and quality thanks to these methods. The budget and schedule performance are under more control. The reduction of on-site manpower, increase off-site. We will talk later about the industrialization of the construction. Constructions in the end construction sites are greener due to less waste being generated, less noisy, safer due to working with assemblies and module produced off-site, and less annoying for surrounding neighborhoods. On the left image, you can see the Sky City building already planned a few years ago in China, and this is this 202-story tower with more than 838 meters height, 10 more than Burj Khalifa in Dubai. He's estimated to be constructed by prefab and precast methods. Okay, it's planned to build this building in less than 90 days, with an average cost per square meter around a half or one-third less of Burj Khalifa. Precast construction isn't nothing new. Okay? Builders in the United States began selling kit homes in early 1900th century. And European governments turned to off-site construction after the Second World War to address housing shortage. Technology from more than 50 years ago helps building future cities. You have here on this slide an example of a not very high tower building in Sweden. Okay, you can see that this is a quite futuristic building, very nice shape indeed. Okay, it has been developed by architecture design more flexible than ever. Okay, prefab construction make it possible to organize and assembly modules according to the building requirements. Moreover, 3D software is automating the internal design of apartments and other rooms in a very fast and easy way. All of this brings me to the core of the current technology, what is said or named design for manufacture and assembly. This is the practice of prioritizing manufacturing realities and assembly workflows while designing a product experience. Offsite construction may be used to describe the assembly of parts before they reach the construction site using processes similar to what will be found on site. You can see above. Automatic manufacturing on the right describes heavily leveraging machines and model-based designs to prefabricate components. This approach reduces the need of labor overall and improves efficiency, traceability, productivity, and quality. Automation is critical for gaining the maximum productivity benefits of an offsite approach. Let's go ahead with prefabrication. Next block. Prefabrication is an umbrella term used to describe all processes in which some components are assembled prior to arriving on site. Often, this term is too vague to identify the level of potential labor savings achievable. Let's go to the next step, modular construction. Often refers to the process whereby transporting sections from the factory to the construction site require them to segment without regard for an on-site installation. In the interface between these components are such that skilled laborers or tradespeople are required to connect them. They have not been engineered as modules designed for efficient assembly. The module-based design describes the use of a single virtual additive referential of a project with progressively increasing dynamic datasets that communicate seamlessly. Physical, dimensional, characteristic, and behavioral data are integrated into a single model that supports a project's full life cycle, from design to development to operation. Okay? In construction, a model-based approach incorporates geometry, systems, performance simulations, process simulations, requirements, constraints, timelines, and so on. We will see the BIM, building information modeling, from the perspective of a machinery manufacturer is also important, okay? And more vital for the building construction projects. From Comansa, we are working for 2-3 years in developing these 3D blocks of the tower cranes in order to provide constructors and rental crane companies of this model in order to achieve the complete digital management of the project. In other words, DFMA, Design for Manufacture and Assembly, has the potential to transform the construction industry. On this picture, you will see how a precast facility looks like. More automated and complete process. It seems to be a safer place, better for many people than in the construction sites. On this slide, on this picture, you can see a truck loading a precast module. Duty transport is required now from the offsite facility to the job site. New logistics challenges come up into the context. Proximity from the precast factories to the job sites, another related issue, affects and costs. On this slide, you can see a 3D software of a building management software with 3D and 4D. 3D refers to visualization of the building itself, whilst 4D, the fourth dimension, takes into account time simulation, construction scheduling, and construction sequencing. We are talking now about the 5D, 5 dimension. This 5 dimension estimate and simulate cost, productivity. The 6D takes into account sustainability and energy analysis in operation. 7D, life cycle and maintenance, and 8D, safety. I have read some white papers and articles talking about 9D, too much or too many dimensions. I think they are enough. We have to focus on the 3D and 4D. We need to be realistic. And as a tower manufacturer is what we are doing. Definitely, job site is becoming a smart place where the tower crane gains in importance. And it is the heart of the construction project and runs the pace of the construction. Reliability of the crane is vital, more than ever. Now we will go to the point of the tower crane requirements. First of all, the part sizing. Precast parts goes from 6 tons to 11 tons, and we should take these precast parts from 30 to 50 meters deep length. PPVC modules, based on this arrangement, modules from 12 to 18 tons, it's called a PVU. We will talk later about that. Modules from 18 to 22 tons, and modules from 25 to 39 and more tons. This brings me to the first requirement. We need a comprehensive product range of tower cranes. Okay, find the right machines, rate loading capacity at a distance is a must, it's mandatory. Regulations of each country or customer have an impact on this decision, but part sizing make as a tower crane manufacturer has a comprehensive and a really wide product portfolio. Site constraints are buildings in the construction sites. We have not only one, but more buildings in the same construction site, local regulation, as I previously said, and the need for an optimization of the load chart. The second requirement for tower cranes is the adaptability. Different configurations available to match the requirements. Alternatives available for the planner thanks to the modularity of the crane. On the right picture, you will see a datasheet of one of our flat top cranes, the 650. You can see that we have different jib configurations, different counter jib configurations, and in the end, modularity of every model in order to provide constructors and rental companies the adaptability for the site constraints. Third, usually one crane per building, but sometimes we need to work together in a crowded site and more than one crane need to be working at the same time. Specific pickup points and placing points close to each other. Okay, we need an optimum layout, and this normally is the precast. It's a repetitive work. We pick up the load from one place and we place this load in another close point. The third requirement is the compactness and robustness of the cranes. Okay, flat top design will give a good solution for having a better overlapping feature, a more efficient job site in this sense, a more rational layout. Okay, we will talk later about flat top, but this is the ADN of Comansa, and this provide our customers a better overlapping features and a better fatigue resistance in terms of crane operation. Precast also affects to the loads. We need to work with heavy loads, and these loads need to be precisely placed. Heavy components need to be placed to avoid damage and to ensure a safe operation. The fourth requirement for tower cranes is the smoothness in operation. Frequency inverter control machines and micro speed feature are a must. Not slewing, trolley, and hoist movement must be controlled by frequency inverters. And the construction is growing, and we can see that we need a faster construction by concept, and because we have to shorten the usage of period of time of the crane in the job site. And we see a trend in India and in other countries, an increased demand for rentals, new business opportunities depending on the country and the needs of construction players. The solution definition. Third, projects where precast is used for construction are usually in a very congested areas that cannot be on construction for a long time. For this reason, construction is key. Okay. In these cases, layout optimization and productivity are mandatory, which leads to a layout crowded of cranes working together. You can see on the right picture around 21 cranes on this project. This is more than one crane per building and per area. We need to define the jib length adapted to the max load with a min span required, and the counter jib as short as possible to avoid boundary overflying. The different levels of precast are precast blocks that are around 6 and 11 tons of loads. The PPU named prefabricated pre-finished unit. These are loads from 12 to 18 tons. The PVU, the prefabricated with bathroom unit. These are modules from 18 to 22 tons, and the PPVC, okay, above 25 or 40 tons in some cases. On this slide, you can see that there is defining the load requirements per jib length is one of the most important inputs for the crane definition and placing. Engineering analysis and study take part in a pre-construction stage. You can see on this example, this is a case study of 4 big cranes, 50 tons maximum capacity cranes in India. And we have to define, together with engineering and architecture departments, the tower crane manufacturer. We really believe that we have to provide solution on this. Engineering analysis, as I said, is also important in precast construction projects. And I have had it, this slide, because repetitive maneuvers of the crane, picking loads from one place to another. Brings me to the idea that the autonomous technology will be in the near future something that we will see in tower cranes. Tower cranes now are manually operated by crane operators, crane drivers, but we can see a tendency of autonomous technology in cars, other industries. The model real-time 3D worksite is here. We have now, I have talked before about the 3D, 4D dimension, and we have the 3D worksite already in our computers, in our screens. We can go ahead to identify crane-specific capabilities, identify load characteristics, determine all possible crane movements, okay? Calculate correlating load sway. So we can advance an assistance for the operators. This will be a second stage. We can also plot all safe trajectories from pickup to drop off. And we can think late afterwards in autonomously transport load along the fastest path. Okay, continuously monitor and modify the lift plan. And this is not to be implemented next year, but we have to work as a tower crane manufacturer on this together with technology brands. Okay, so the construction environment is quite complicated, and we have to take into account many inputs, not only the pickup and drop off places of the loads and so on. So there are another important factors involved in the construction environment. But the less random is the environment, and we are going ahead with the industrialization of the job site, the more automated the tower crane maneuvers can be. I have had it, this is my last week in a tower crane conference in France. We have the possibility, we had the chance of managing different tower crane simulation software. These companies are willing to participate and actively collaborate with tower crane manufacturers in this autonomous technology. And this is the real life. They have already implemented in some rental companies some prototypes that I'm sure that we will see in this kind of projects where precast and industrial offsite are available.
Yeah, Xavier, sorry to disturb. You have another 5 minutes, so
Okay.
you can wrap up in that time.
Okay, thank you. Yeah, I'm finishing. I would like to show you some of the key projects, precast projects around the world. Singapore has been a trend-setting country in this industry. You can see here short jibs and short counter jibs working with high loads. This 121 LC 1050 crane has 50 tons maximum capacity. You can see that there are two cranes for one building that is built in a very short period of time. Another picture of the PPVC modules taken from the pickup place on the ground floor and drop off on the top of the building. Another two pictures of this project in Singapore. Here, also in Singapore, another project, similar cranes. You can see that this is not a high building project. Here in Sweden, you can see the Norra Torn. This is also a high capacity tower crane, the 750 with a portal base. You can see in Europe it's quite common to find this portal base for tower cranes, as we cannot disturb the citizens walking around the streets. Going to India, we have a Aurobindo reality project. We have Mr. Malik in the meeting that we can give you more details about the projects, better than me, for sure. Another project in India with two types of model. So we can show now 2, 3, 4 projects around the world. India, we believe at Comansa that is one of the countries where precast will bring the opportunity to have a safer and a faster construction job sites. And we will see and we develop our product according to these requirements told today. And I have here one video, it's 40 minutes video, but I just wanted to show you that this is in China. This is one building planned in 2015, 6 years ago. This building was, they were planned to build in less than 4 months and a half. Okay, 3 stories per day. The industry, the offsite factory was close to the job site, and China is another country where precast is taken more and more the lead of the way of construction. And with these last images, I'm finishing my presentation. Okay, now I will be happy to answer your questions.
Again, myself, Bosle. How you plan the life of or load carrying capacity of crane over the period of usage? Maybe after 5 years, 6 years, 10 years down the line, how you predict the load carrying capacity of the cranes? Do you consider this factor of safety in lifting the weight, or how you consider this?
Mr. Malik, I give you the floor if you want to answer and participate in the meeting. Or
Yeah, sure. Thank you, Xavier. See, Mr. Bosle,
I think
in tower cranes, our we do have a rated load, and our rated loads are there. We do a periodical checks in between. Okay, our teams are there who can do the periodical check. There is no such norms of like in mobile crane. There are norms like you have to reduce the capacity. It's not in tower cranes. Tower cranes are a longer life machines, but in between, definitely we do the checks by our own engineers.
so. Means the machine which we have been installed newly, suppose
Yeah.
it is a 16-ton capacity. So after 10 years down line also we consider the same load
Same.
carrying capacity,
Yes,
provided you
yes.
are been maintaining the machine, the
Yeah.
braking system and all this. Yeah.
Right, sir. Right, sir. Very right, sir. And this is world over. This is world over. Same now. Yeah.
Okay. Thank you.
Thank you.
thank you.
Yeah.
Goodbye.
Thank you.
Goodbye. Thank
Yeah.
you. Thank you.
Thanks.
Thank you.
Thank you.